And for anyone who needs or would like, the live transcription is turned on, so you can just navigate to the bottom of your Zoom screen to see the full transcript and or subtitles. And we welcome you, if you have questions tonight during the webinar, to use the chat, put them there. We'll be monitoring the chat for your questions. But also you feel free to raise your hand if we get to a point where the guest speakers are accepting questions. You can use the raise hand feature at the bottom of your Zoom window. And I think as we grow tonight, there'll be more people coming in. I think that's probably the best way to do it, is either the chat or raise your hand. So that way we can kind of keep it in an orderly fashion. So just to give you a sense of how tonight is going to go, we're going to do some introductions here in just a moment. We're going to give some background on the APCSA exam. As we know, we have a wide variety of educators that are with us tonight. Some of you are experienced with CSA for many years, and some of you are relatively new. So we just want to kind of paint that picture for anyone who is joining us. And then we have two guest speakers that will be joining us to talk about using FRQs, using the close reading approach for FRQs, to help your students with getting through and solving FRQs as a strategy. And then we're going to look at how to score a sample FRQ if you have not done that before. At the end, we're going to give you some additional resources. We're going to tell you about some awesome and free professional development opportunities that are available to you possibly for this summer. And we're going to have some just open Q&A time with our guest speakers who are experienced CSAwesome teachers. So with that, I think I should introduce myself. So if you have not met me before, my name is Leigh. I am the Curriculum and PD Coordinator for the National Center for Computer Science Education. I have worked with both Mobile CSP and CSAwesome since their inception, and I help with the curriculum development and oversee the professional development in our facilitators. So I see lots of familiar faces and names in the webinar tonight, so it's good to see you all. If you are interested in doing professional development with us or doing any continuing education credits, you most likely will have some contact with me, and I look forward to working with you all. Tonight, we're joined by two guest speakers who are experienced CSAwesome facilitators. I'm going to hand it over to Leigh Fitz first.
Hi, my name is Leigh Fitz. I am a computer science teacher at Princeton High School, which is located in Virginia Beach, Virginia. I have been teaching computer science for many years now and have been using both CSAwesome and Mobile CSP as well. I remember when I went through the training myself as a new teacher and have been using it ever since, and just love these two curriculums and am excited to be here tonight. Thank you.
Thanks, Leigh. And also joining us tonight is Benjamin Smith. Ben?
Yeah, hi everybody. So I teach computer science as well in Roland Hall School in Salt Lake City, Utah. I also have been a facilitator for Mobile CSP as well as CSAwesome, and I am going to be doing my second year of FRQ grading for the College Board for CSA. So hopefully some of what I've learned from that process will come out tonight in helping you prepare students for that. And I'm looking forward to helping out as much as possible. Thanks.
Awesome. Thanks, Ben. Happy to have you here. And I'm excited for you all that are joining us to be able to hear from both Leigh and Ben. They're both awesome educators and advocates for computer science. And they've also been great in their role as PD facilitators. And it's a potential, if you were to take PD with us, that they could be your PD facilitator in the summer. So with that, you know a little bit about us and you're going to hear from us, but we also want to know a little bit about you. So feel free, if you haven't already, to introduce yourself in the chat. while folks are sharing kind of who they are and where they're from, and maybe your experience with CSA, I can share, based on your registrations, just some general information that we received. And we do know that most of the registrants tonight were high school educators. We did have some elementary and college and university folks as well. We had folks register from over 27 different states, with the most registering from California and Texas. So you may see in the chat some local educators and someone that you might want to connect with. So be on the lookout for that. And you all had a very wide range of CSA and Java background. So I would say about a third of you had been teaching CSA for more than 3 years, but everyone else was either in your first year, possibly your second, or you had never taught CSA before. So you would all fall in our range of being new to CSA and Java. And we were interested to see that of the folks who registered, there was about a fourth of you that are not currently using CSAwesome, but we hope that tonight you'll get to see a little bit of our kind of take on it, and you might be interested in checking out our free curriculum that's available on Redstone Academy. So thank you to those who have introduced yourself in the chat. Again, feel free to just check the chat, see if there's anyone that you're interested in connecting with that maybe is locally around you, or maybe you recognize a name that you've seen in the forum if you're a part of our Teaching CSAwesome forum and you want to just say hi. Awesome. Okay, so I am going to kick us off tonight with telling you a little bit about the AP CSA exam. Again, just to give some context, most of you probably do already know this information, but just kind of bring us in and see where we are focusing in terms of what FRQs are. So the AP CSA exam has two parts. There is a multiple choice portion, which is about 90 minutes that students get to answer a total of 40 multiple choice questions. And then they are asked to answer what are called free response questions. So they're given 4 questions that they need to answer in 90 minutes. And that free response question portion is the portion that we're going to talk about tonight. So when we look at the multiple choice portion, so the first portion of the exam, students end up seeing a total of 40 questions, and they're going to fall into these sort of 4 categories. They're going to get questions on program design, algorithm development, code logic, code testing, and documentation. And if you are interested in seeing some of the multiple choice questions, some sample ones, you can look at the AP CSA course and exam description. So if I say CED, I'm referring to course and exam description. If you've been teaching AP CSA, hopefully you know what that is. And if you see behind me, actually my binder, my green binder behind me, and you may have one too, but it is available online, and you can check out the multiple choice sample questions in that CED booklet. So the second portion of the exam, second part, which is what we'll be focusing on tonight, are the free response questions. And again, students get 4 questions. And it is announced that there will be 4 different types, or each question will have a topic that it will focus on. So question 1 will be centered around methods and control structures. Question 2 will be focusing on programming a class. Question 3 will be on arrays or array lists, and question 4 will be on 2D arrays. So again, these 4 different free response questions are FRQs, and students get a total of 90 minutes to answer them as part of the AP CSA exam at the end of the year. So I keep saying FRQ, and again, I understand that some of you may be familiar with this, but I just wanted to break it down a little bit more in case anyone is newer to FRQs. So a free response question, FRQ, students are given a prompt and they are given a blank answer sheet, and they must handwrite out their answers or the code that is in response to what the prompt is asking them to do. An FRQ is often going to involve some type of Java content paired with a skill that they've been learning about. And just so you can see an example, we have in CSAwesome, we have lesson 4.11, and I can open this up. And so in Runestone Academy on the ebook for CSAwesome, we have this 4.11 FRQ, which is on programming an AP calendar. And you can see the structure of how there is a prompt that is given, and then students are asked to break down a portion of that prompt and answer it. So in CSAwesome, it's meant to be interactive, but the actual FRQ on the exam is going to be handwritten on a piece of paper. That is important to note. And we're going to talk a little bit more tonight, the guest speakers are, about what exactly does an FRQ entail and how do you go about solving it and how do you go about scoring it. So we're going to break all of that down. This is just to give you a kind of little bit of a background on what goes into an FRQ. So the one that I just had up, I know we didn't look at it in depth, but just saying for reference, that particular one on programming a calendar, it is on the topic of methods and control structures. So if you were to navigate to lesson 4.11, that would mean when you're looking through, you're going to see some involvement of having loops, the control structures of loops, if statements, and you're going to see that it's going to cover skill 3C, which is in the CED, and that is about writing program code to satisfy method specifications, and that could be meaning to use expressions, conditional statements, or iterative statements. So there's that pairing of here's some Java content, here's something they need to know, and a skill that they need to be able to do, and putting those together. So there are lots of sample FRQs that are available on AP Central, and there's a link in the slides. If you have that slide on slide 10, there's a link if you haven't been to AP Central to see those samples. Definitely check it out. We're going to go through, I believe, 2 tonight, looking at 2 kind of specifically with you, but there are lots after each exam each year, is my understanding. They release some of those for you to see what students saw on the exam. I see Ben put that in the chat. Thank you, Ben. All right. So here, I just wanted to show you again, kind of briefly before I hand it over to Leigh. This is the same thing that's in 4.11. This is sort of what would be on the FRQ prompt that the student would see. And you can see how I highlighted here the 2 places where they explained there's something for the student to be implemented. So they're saying in part A, you're going to implement this method, and in part B, you're going to implement this method. So being able to actually pick this out of a prompt and understanding what needs to be done is part of solving the FRQ and what we're going to talk about tonight and how to help students do that. All right, so I'm going to hand it over to Leigh, and Leigh is going to help us understand how do we use the close reading approach.
Thank you. So this is something that I have borrowed. I wish I could take credit for creating this myself, but I'll give credit where credit's due. And it's an approach that I've used with my students in my classroom from the first FRQ that I give them. One of the things, if you've been teaching for a while, you probably already know this, but if not, these FRQs can be a little intimidating for the students up front. When they first see an FRQ, an example of one, which I usually try to hold off a little bit till maybe around unit 4, where I give them an actual one that's been released. They're a little intimidated. So this approach is going to help them to learn how to really break down the problem and give them a lot of tools for attacking it. So Pauline, if you wouldn't mind going to the next slide. When I do this in class, there's a couple of materials that are going to be needed, and we have some links for you in the slides that will be helpful for what we're about to look at. But Jamila Mitchell is the person who developed this. And like I said, I fell in love with this tool as soon as I saw it and couldn't wait to implement it in my class. And I feel like it really has made a big difference at acclimating my students to the FRQs. Now, this isn't something you want to use all year. This is something you'd want to use towards the beginning, and you have to kind of wean them off of this as time goes on, because, for example, it's going to use highlighters, and they are not allowed to use highlighters on the AP exam. So what my students tend to do is kind of adapt and start making little symbols instead of highlighting. But some of the materials you're going to need, you'll want, of course, the copy of the FRQ, and I like to give my students a hard copy of the FRQ to write on, because as mentioned earlier by Pauline, they will be writing on the exam. So they do need practice writing code. They need to, kind of judge space. They need to judge handwriting, make sure it's legible. What are you going to do if you need to make corrections, all that kind of good stuff. So I actually give them a hard copy of the FRQ. Then there is another link for the handout with the directions. And I will tell you that I do kind of modify the directions based on the FRQ that they're dealing with. You'll always want a copy of the scoring guidelines that go with that FRQ. And then you need a couple of highlighters. Typically about 5 different color highlighters is what is used on these. All right, so let's, what I'd like to do first is I want to, if you are able to, please open the Step Tracker FRQ. And I want to give everybody just a little bit of time to actually read that question. So thank you, Pauline, if that's what you should be looking at. And like I said, let's just take a few minutes and give everybody a chance to read that. Okay, so the closed reading approach is divided into 3 steps, and you've just kind of started the first steps. This is what I always have my students do, is just do a quick read through. So our first step is to just read it once and get the gist of what's happening here. You're going to then ask the students to get out their highlighters and especially the first couple of times, we really go through this together as a class. And then as we've done a few FRQs, I will ask them to try the steps and then maybe look with the table partner and compare notes. And then eventually they're kind of on their own to go through the steps. And then we talk at the end as a big group. And, you know, you just kind of start weaning them to be more and more solo on this. But what we're going to ask the students to do is, as they are reading through this question, they're going to use highlighters to annotate a few things. And the goal of the highlighters is to try to help the students learn how to separate out the pieces. Now, this particular FRQ is one of the questions that relates to writing a class. As Pauline mentioned, there's different types of questions. This one comes to writing a class. And what I ask them to highlight gets adjusted depending on the FRQ. So in this particular one, I'm going to ask them to use one color, I chose yellow, to highlight information about the constructor and any instance variables. And then we'll have another color to highlight names of methods, a third color to highlight any kind of return values or return types, a fourth color for any information on parameters. And then I always save a color for things they're not sure of, things that they want to highlight that they just really aren't quite sure how this fits in at all. And so that kind of goes with this type of question with the class. Now, there are other types where they might be writing methods and there is no constructor because it's not a class question. So as I mentioned, you may adjust what you need them looking for based on the type of question. All right, so Pauline, if you wouldn't mind pulling up the directions for the closed reading approach. And in just a second here, I'm going to ask you guys to use the chat to share some of your thoughts. All right, so we're obviously not going to have highlighters out and do the actual highlighting, but what I'd like you to do, I would, if I was doing this with my students, I would tell them all to get out their yellow highlighters. And what we're looking for is information about the constructor and any possible instance variables. So let's take to the chat. And what do you guys think? What put in the chat anything you think might have to do with the constructor or anything that might be a possible instance variable. What do you think might be part of the constructor or instance variables? All right, somebody said the second sentence where we have a step tracker object is created with a parameter that defines the minimum number of steps that must be taken for a day to be considered active. Good. Yep. So anytime we're making an object, very good. That's pretty much describing our constructor. The second row in the chart, so not the header row, but the one right after that. Good example of using a constructor. Yep, because we're creating an object there. How about some of the instance variables? What do some people think might be our instance variables? They, unfortunately, I don't think they can use colored pens on the AP exam either. Am I correct? Yeah, they can't use pens on the AP exam. They really kind of limit them on what they're allowed to use. I think it's either pencils or blue or black ink, if I'm not mistaken. Mm-hmm. So you can have two colors, blue and black, but I don't think we can have more than that. Exactly. Yeah, we like I said, the highlighting we do at the beginning, and then what my students have started doing is instead of the colors, they come up with different symbols for themselves. Like they'll star one, or maybe a plus, or a check mark. Then they'll come up with things like that. Underlining, circling, squares. Yep, all this is good stuff too. Okay, I have a TR is the instance variable. TR is actually the name of an object that they're going to be creating, so not an instance variable. So what are some of the things that You know, when you want them thinking about instance variables, we need to be thinking about some of the things that we have to keep track of. The steps, good. And you can kind of think of the steps in two ways. We have the minimum number of steps that they have to take, but then we also have to kind of keep track of the total number of steps. I see active days. Yep, we have to keep track of the number of active days. And I think the only other thing we really need to track is the number of total days, because some of them may not be active. So we have to have our total steps, our minimum number of steps that we need to be considered active. We have the number of days that they're going to be tracking, and then the number of active days. These are all great. And so these are all the things that we would hope the kids would highlight in the yellow color. All right, the next thing we're going to look for are names of methods. And this one, they stand out pretty well in this one. They're pretty explicit in this question about method names. And I tell my students to be very, very careful, because if they give you method names, you have to use them. You can't modify them because you think your name sounds cooler than theirs is. So let's identify the method names. And if we were in class, I would have my kids highlighting these in green, but let's just go to the chat and see if we can get the names of the methods. Let's see if we can get them all. What would be the methods that we're writing? Add daily steps, for sure. Active days, for sure. And I think I'm looking, average steps. There it is. Yes, thank you. Average steps. Good. And these stand out pretty well in two places. They're pretty explicit in the bulleted items. I mean, it pretty much says, and the following methods. And then I liked how some people were adding some parentheses and some parameters that you can see pretty clearly in the chart as to how they're calling the methods. The students need to learn based on how they're calling them, whether or not you need the parameters or not. All right, excellent. So the next item, I'd ask my kids to get out their blue highlighter, and let's talk about return values. All right, so some of these methods return values and some do not. So I would ask my students to think about those. Now, the return values are pretty clearly shown in the column in the chart, that middle column. So they would be highlighting all of those blue. But what I want to do is we have to think about not only what is the return value. They give a pretty clear example, but I liked my students to follow that up with a pen and write down what type it is. So if you look at the chart, we can see that active days has a return value. What type? I see it in the chat already. Good. Days is an int. How about average steps? What kind of thing is it going to return? A double. Excellent. Excellent. And add daily steps. What return type would add daily steps have? No return. So we have to put something there though. What? There we go. Yes. Excellent. Excellent. So void is what we use when we need to return when we don't need to return anything, excuse me. There's a question that I'm gonna pass to you, Ben, if they put float instead of double.
Yeah, I mean, I believe that in the case of it is not considered one of the errors that would lose a point. So as long as it would handle the data properly and a float would handle that data properly, you would be just fine.
Excellent, thank you. The next thing we're going to talk about are parameters. All right, so again, we have these three methods, but I also want to talk a little bit about the constructor here as well. By the way, constructors, hopefully we need to make sure we drill into them that there is absolutely no return type at all on a constructor, not even void. Constructors have no return type at all. But parameters, all right, what kind of parameter would we have for step tracker? What kind of parameter would they be? An int, good. Active days. A parameter for active days? None. Good. You can tell by the chart there's an empty set of parentheses, so there would be no parameter there. How about average steps? No parameter there as well. And then how about add daily steps? An int. Excellent. So again, those we'd all be highlighting those in orange on our paper. So by now our paper should be getting fairly colorful if we were doing this in class. And then again, I'd give my students a chance to use the pink highlighter to kind of highlight anything that they're not sure about. And then I would always give them a chance to ask questions about whatever they may have highlighted in pink. So once they've had a chance to do all that, we want to give them some reflection questions to think about. I like my students to write these down, but some of the questions you're going to be asking: what's the main goal of the overall problem presented? What are we trying to accomplish here? In this case, we're trying to write an entire class. And I like to really remind my students that classes tend to kind of follow a structure. You always have your class header. You always want to follow that with your instance variables, then your constructor, and then your methods. And they just want to kind of get used to, okay, anytime I see a class question, that's the order I'm going to be going here. Class header, instance variables, constructor, and then additional methods. Then have them answer what are the code segments in the table intended to do. That's another reflection question. Why is this table here and how is it going to help us? And hopefully the students will realize that it's kind of setting you up and giving you examples of how these are going to be used. You can see parameter versus no parameter. You can see return type versus void. And the comments even help you to kind of see how things are moving along. And then what concepts or information stand out to the student, ask them that question, make them reflect on that. And then, of course, what questions do they have about approaching this topic? So again, this is just our first read through. So we're just kind of trying to find information, highlight things, and answer some reflections. And again, the document, you'll want to edit it for the free response question because what you highlight might be different for different FRQs. All right, the second time though, we're now going to go through a second time. So Colleen, you could go to the next slide. Now that we've got a general idea, our second phase, we're going to dig a little deeper. We've kind of already done this already, but have your students go back and write the data type next to all of the instance variables and parameters and return values. So we already talked about the parameters and return values. We didn't quite mention the instance variables, but you can probably see, since we're talking about number of steps and number of days, we're going to want all of those to be ints because we're not going to do partial steps or partial days. And then you want to present the kids with the scoring guidelines. All questions are worth 9 points, and they'll want to look at how those points are broken down. And what we want them to do, again, at first, again, I kind of, as time goes on, you kind of back off on these things a little bit. But now that they've identified some things on the FRQ on their own, using the scoring guideline, we want them to see where these points are going to come from. So you'll have them go to the stuff they highlighted, figure out what things are directly relevant to the scoring guidelines. I have them put little asterisks next to them, and then a number representing, well, which line on the scoring guideline 1 through 9 would that particular thing go with. So for example, on the scoring guideline, the first row talks about the instance variables. Well, those were all kind of in that top paragraph. So we'd go near some of the things that we highlighted in yellow. We'd probably put a little *1 next to those. The next 2 points, 2 and 3, deal with the constructors. Well, there's only one, so constructor, singular. So I would go to where we highlighted the constructor in yellow and put a little star next to that and put 2 and 3. And then we work our way down to the 3 methods. We've got 3 points for the adding the daily steps. We've got 1 point for the active days method, and then we've got 2 points for the average steps. So again, they kind of want to go through where they highlighted those and just mark where they see the appropriate points being given. So they need to, as they work through the FRQs, you don't want to just teach them the FRQs, you also want to teach them about how they're scored. Because if they get a feel for what's being looked for on the FRQs, they start to get a little bit more comfortable and they say, okay, I know every time I get a class question, they're going to check my instance variables and make sure they're private. They're going to check my constructor and make sure it's set up right. They're going to be checking these methods and making sure I have the right header. Do they return something? If so, did I return it correctly? And they get a feel after having seen the scoring guidelines over and over again, not only how do the FRQs work, but how are they going to be scored? And the more familiar they're with all these components, the easier the FRQs are going to be for them, or at least a little less intimidating. And it's also good for them to know, I always tell my students, nobody should get a 0 on the FRQ. You can do some of this. Even if you really have no idea what this thing is talking about, I bet you can squeeze a couple points out of it somewhere. And again, if they just remember, all right, so I got to get some instance variables, and I got to make them private. I got to make a constructor. You know, you may not make it correctly, but you might get a couple points here or there. And Ben's going to talk more about the points later, but they really can, even if they're very confused, as long as they try and don't leave it blank, they can probably scrape some points out here or there. Hopefully, though, they'll start getting less intimidated and get a lot more points than they realize. All right, so then after the second read through, where we've kind of compared it to the scoring guideline and we've figured out which things go with which points, then we have our third read through, and this is where they're going to put all their pieces together. This is where they're going to try to construct their solution. Using all the information that they've gathered, I like my students to kind of outline first. And what I mean by an outline, I kind of play around with different things. Sometimes I'll do like a table talk. My students sit in groups, so I'll have them do a little table talk, say, I don't want you to write anything down. I just want you guys to talk it out. In English, not in Java speak, is what I tell them. In your own words, tell me how you're going to go through this FRQ. So sometimes we'll do a table talk. Sometimes I'll get them, have them get out pen and paper and sketch an outline of it. Again, trying to use more pseudo code than actual code, just give us an outline. So there's lots of different formats that they want to do first, but I always tell them, I know you get intimidated by the time. It seems like a long time for 4 questions, but it goes by quickly. But I tell them a lot of times, if you take just a few minutes to process it first, the writing part will go actually a little bit faster. So I want them to always take that little bit of time to think it through and strategize first. And then once they've done that, we're going to have them write down their solution. Have them take their solution and compare it to the scoring guideline to see if they think they've got the points. Sometimes I'll have them trade papers with a partner and score somebody else's. Like I said, I try to change it up here and there to give them a couple of different ways to approach this. And so take your partners and score theirs, and then talk about it. And then again, we've got some reflection questions that go with that as well. Which rows did they get right? Which rows do they think they achieved? What information did you highlight or annotate that ended up being helping you in the development of your solution? Which rows are you still confused about? And you definitely want to address those as a class. And were you unable to identify relevant information in the FRQ for a particular row? And if so, which one? So a couple of, again, it's important to have the students really reflect on what they're doing. And then we usually kind of come together as a class at the end and talk about things like, all right, so how did it work? let's look at some samples. One of the other nice things from AP Classroom that you can get is some student samples to look at. But just then, kind of construct the problem, talk it through as a class, and make sure everybody understands the solution. So that in a nutshell is the closed reading approach. Like I said, hit it heavy at the beginning, but then strategize on how to wean off of it, how to make adjustments so that we don't have to use the highlighters because we can't use them on the AP exam. Some people had some great tips there. Like I said, my kids tend to use symbols, but I like the circle versus square versus underline. Those are all good tools for the trade. So I'd like to just kind of open it up for some questions that you guys might have. And feel free to either put it in the chat or unmute and ask.
I have a question.
Yes.
Can you hear me?
Yes.
Okay. I have a question just about the FRQs in general.
Mhm.
With the writing classes FRQs, those ones seem to be the most straightforward in the sense that, like, I know that it seems like students can usually get 3 to 5 points by at least writing the class header, the instance variables, making them private, correctly initializing those instance variables in the constructor, and then writing the method header for each of the methods. It seems like you can generally squeeze out 3 to 5 points if you know that, even if you're not exactly sure what the correct algorithm is for the method.
Yes.
That doesn't seem to be quite the case for the other FRQs, in the sense that there's not a sort of rigid structure. But if that is the case, if it is kind of similar to the writing classes FRQs, where it's like you can always get some points by doing this or doing that, if there is like some like gimme points for those other FRQs, I would love to know what they are. If that
Yeah,
makes sense.
and this goes to where I was talking about where you want to edit what they're highlighting based on the actual question. So for example, let's say we're doing something with just generalize the first question where it's, basic, maybe an if else and loops and things like that. Always make sure they're highlighting the return stuff, because I always tell them, even if you have no idea what you're doing, if it's asking you to return something, like let's say you figured out it needs to return an int, then declare an int and return it. And that might be enough to get you, it might be enough to get you a point right there. So identify what do you need to return here? Identify, and that's, like I said, that's where I edit what goes next to those colors. I kind of pre-pick out what are the key things that I need them to look for this particular question. And I kind of design my colors based on that. Sometimes I'll have them highlight anything that looks like it's going to be a control structure, like an if or a loop or things like that. And so they know they're looking for those key control structures. Oh, I know I have an if statement. I always give them a heads up where if you have a bulleted list of conditions, that's going to be a bunch of if or if else statements. So look for those conditions. What are the conditions? Highlight those a different color. So you structure this to kind of guide them at first, and then through repetition, and I cannot stress enough, please give them lots of FRQs throughout the year. Don't ignore them until just before the AP exam. You want to embed them as much as possible, probably starting from Unit 4 on. And over time, they will start seeing a lot of the, oh, this was kind of like that one. Oh, I remember something similar to this. Oh, I remember when we saw this, we always had to do this thing. And they do tend to get used to it as you go along, but guide those colors at first for them. What do I really need them to look for? And that's what you're going to make these colors.
Okay, thank you.
Mhm. Yeah, somebody mentioned they do a lot of these at first, and then they start removing the scoring access, which is good. This is, again, this part of that weaning them off of this. After a while, you want to take away the grading guideline point or part of it, so that they're identifying and going straight to the solution. And then after they've constructed the solution, maybe bring back the scoring guideline and let's see how you did. Because yeah, you want to start taking away little bits of this as you get closer towards the end. So that's a good one. You want them to see the scoring guideline first, so they can get used to what exactly are they looking for, because that's the biggest question. I've got this problem. I don't even understand what they're looking for. I can't even understand this question itself. They are going to have a hard time reading them at first. This is very intimidating, how much reading. I mean, there are some questions, this was a rather short one, but there are some questions where the question itself is 3 pages before you even get to the part you have to write on. And so they have to get used to reading them. They have to get used to sorting through all of this mess and figuring out what exactly do I need for this problem? What is it even talking about? What am I supposed to be doing? And that's what this is supposed to guide them through, figuring out how to wade through all this and pick out what exactly are they trying to do in this small piece. Some of them have a part A and a part B. So sometimes I'll have, it depends again on the question, I might have one of these closed reading approaches just for part A. And then I have a second one that's geared just for part B. Sometimes I'll lump them together. You know, again, it just depends on the FRQ. Somebody asked in the chat about time. So if you think about it, they have 90 minutes to answer 4 questions. So you want to try to get them down to approximately 20 minutes per question. So that's what I tell my students as a goal. By the time, you know, we spend a lot of time on them at first, much more than 20 minutes on a question. We'll spend much more time on that at first. But as you know, like right now, I put them on the clock, 20 minutes to get me a solution, because we're getting awfully close now to this exam. So now they're on a clock where you got 20 minutes to sort through all this stuff. And I mentioned earlier, it can be very nerve-wracking, but I tell my students, the planning is worth the time. It really is. The planning is worth the time. Ben suggested about 12 minutes or so reading it, and then 8 to 10 minutes on writing your solution. And that 12 minutes should include, you know, like outlining or strategizing. And it is worth spending that time because you just have such a clearer approach when you go to the problem. So like right now, we actually did an FRQ today. I'm trying to remember which one we did. Oh, we did the trio one from one of the released ones where they're constructing a trio of food choices. And as we were looking at it, I said, okay, let's talk it out. And so I made my groups talk it out and do a little bit of a, you know, just kind of a 5-minute talk out this one piece of it. And I gave them a certain section that I wanted them to talk about. And then later on, all right, now talk out this section and so on. So it's worth the time. So by the time they had to write it, they kind of already had in their head what they needed to do. So, and Pauline, I believe I'm about out of my time, if I'm not mistaken.
All right. We'll head into the next part. So for those of you who didn't meet me earlier, my name is Ben Smith. I teach in Utah. And I was a reader for the AP last year. I'll be a reader again this year. I know that a couple of you noted that you're either reading this year or you've read in the past. Kate McDonald, you're on here. You probably know more than me about some of what I'm going to talk about. So please step in and help us out if I step on my own feet trying to help you through this. I will tell you that I began computer science and Java in particular and teaching CSA as a newcomer and a beginner. And it was really, really hard for me my first year to understand this. And so I can't reflect enough what Leanne is saying about the difficulty it is for students, but it's also a difficulty as teachers. We at CSAwesome, we talk a lot about this in terms of professional development. It's not a 1 year and done professional development experience. I think it takes 2 to 3 years to feel even reasonably comfortable in understanding all of the nuances of the curriculum and the exam. So if you're feeling like this is a lot and you're kind of confused and it's a challenge, then you're in the right place, because that's exactly how I think the first year of doing this is going to feel. And I encourage you to stick with it, because actually, as you begin to get more understanding, the process of teaching kids how to go through this becomes, I have the experience, so I can share that experience with them. So I'm going to focus more directly, we'll go to the next slide, on the process of scoring. And so you can feel free to open the prompt. This is the prompt for last year's third question. This is the one that I graded. So I've got like hundreds of times that I've gone over this, starting on, I think, page 10 is where this one pops in. And it is an array list or array. So it's the third prompt, it's different than the one we just looked at. It is a longer one, so you can see that there's there's a full page that shows 2 different classes that we need to deal with. And then it goes into an example for prompt A, which asks you to add members, and prompt B, which is on the next page, that asks you to create a process for removing members. And it depends on certain situations as to whether or not the members get removed or added to a return array. But here we're dealing with arrays, array lists, so they have to think about the process of using, obviously, in this case, loops and if statements and the proper syntax for functioning on these. So I'm just going to kind of give you a basic idea of what this does. You don't have to understand all the details like we may have looked at. Obviously, with students, I would be going through that highlighting process, or if this is later on in the year, we might simplify the process a little bit. But it's basically asking them to take the first part says you take a 1D string array of names with a graduation year, and you just add these new objects. So here we have to understand how to use 2 different classes, one that's a class that holds a member of a club, and the other class that is a list of members. And then the second prompt is the one that says, if I give you a graduation year, can you remove all members that have graduated at that year or before, and ask a question as to whether or not they were in good standing. And if so, then you return the ones that have graduated and were in good standing. So you can hear in that description that we have an if statement. Now, in addition to all the things that Leanne does, I have my students do diagrams. They diagram their classes so that they understand the parts of them. UML diagramming is something you'll see in a lot of different contexts for Java. I find it a pretty good way to look. So on the next slide, you'll see a UML diagram of part A. And so I've broken down the reading into a UML diagram, and it's one of the things that some of my students really are attracted to. So the first part mentions the diagram to the upper left is member info. So in other words, there's a class that creates objects of the member info type that have a name, a graduation year, and a Boolean of whether they're in good standing. You can see the constructor is written, and you can also see what methods are given for that. Then you can see the other class called club members that only has one instance variable, which is a member list or an array list of members. And we need to write 2 different methods. So I'm showing you the first one, which is part A. Now I also show, if you can kind of see the diagram I have below, I always talk about the students, I'm like, every method is like a black box. There might be something going in, there might be something coming out, and inside that black box, something happens, right? So one of the points I was going to make, and I've added it to the list, I believe, is students should know how to read method signatures. I give method signatures to my students all the time. The ability to understand when you just look at a method signature, whether it returns something, what parameters it has. And then if they understand what it's supposed to do, it's pretty easy for them to identify what's going to be asked of them. In this case, because we're not going to spend as much time, what it says is for each item in a given array, you add a new member info object to an array list, which is the instance variable. And I've highlighted them in 3 different colors to show you that as a grader, I'm going to look at the response and I'm going to only ask 3 separate questions. They're not integrated questions. They're separate questions. And so the first one is, did they iterate through all of the names in the string array? So do they have a for loop or a for each loop to go through every name in the string array of names? If they did that, and that's all they did, they got a point. It doesn't matter whether or not they did anything else properly, that's it. The second thing I'm going to look is say, did they create a member info object? So the question would be, are they using the correct constructor to make any member info object? It could be just that they did one statement that says member info new member equals, or sorry, member info member equals new member, and then they put the information in there. As long as they've done that, they have created a member info object. And the final one is the question, did they add all of the members to the instance variable member list? In other words, are they using the array list saying member list dot add and then that new member? Now, there are several ways, as there are with all FRQs, for students to approach writing this response. But as a grader, it's pretty easy to see, did they get 1, 2, or 3 points here? And even if a student looks at it and says, look, I know that I'm taking in an array of names and I have to add a new member info object, if they just had the constructor for a member info object, they get 1 of those 3 points. Now, someone earlier said, you know, when you sit down for an FRQ, if you know a few of the things that are in there, you can get 4 to 5 just by kind of stabbing at it. I think that's true to some degree, but I'm pointing out that as a grader, what I look at is their understanding of the full context of the reading. In other words, knowing their algorithms, knowing what the signature is asking for, and being clear when a student thinks about it, what needs to be done in order to accomplish that method. And sometimes we get responses that just have non sequiturs, just little statements, just a list of random statements. And if it's not in the context of what's supposed to be done, they might get close, but not quite there. So it is a point to be made that, again, going back to the reading, careful reading leads to proper algorithmic response, right? So the question about part A, the students would even need to put a loop in their solution. They do need to iterate through the array. That's the first point, but they could still get 2 points. If they created just one new object of the member info type and added it to the member list, they would get 2 of the 3 points. And I had quite a few that I graded last year that would do that. They would just say, oh, I'll just add a new member. Because they look at add members and they think add member, singular. So they're going to get 2 of the points, but it doesn't actually add all of the names in that list, if that makes sense. It is, you know, there's some gray area there, but for the most part, that's how these work. I'm going to click to the next one just so you can see what part B in this context looked like. So note that Part A only had 3 points, part B has 6 points. So don't assume that A and B are going to be equally weighted or close to equal. They're all 9 points, but sometimes they're a much more weighted like this. And so by looking at the prompt, oftentimes students can say, oh, this is going to be the one that's going to have more points, therefore spending more time on that. So this one is the second part. It asks them to return an array list of removed members from a certain year or earlier. And this one, obviously, more complicated because it has if statements and iteration. But you'll notice that it inside of my box, again, there's a single variable coming in as a parameter. There's a single array list variable coming out as a return item. And if they know that there's a return item, they should just go down there and say return. And if it's something new, they should know they need to construct a new one. So if you look at points 1 and 6, if you construct a new array list to begin with, that's going to get returned, and you return that array list at the end, you're all the way through the first point, and you're most of the way through the second point. You just have to see if you can construct it. So you iterate through each member object in the member list. So you go through all the members. That's, again, iterations. So I'm going to look at that and say, did they iterate through every item in the list? Are they using the right name? Are they using the right syntax? And if that's true, regardless of what else they do with them, I'm going to give them 0.2. As long as they went through every item without having an out of bounds error, we're good to go. And then the next part is to say they remove all members in good standing. So in this case, they're just asking, did they call either method, get grad year, or in good standing for any of the member info objects in your list? So they're basically saying, can you call a method on an object in an array list? Because students know they're going to need to do that. And literally, I'll just look and say, did they do either one or both? You get the point. Even if it was not done correctly in the context of the loop, or they didn't ask the right if statements. So the next one, number 4, is the question about your if statements for the most part. Distinguishes the correct status with your if statements. In other words, adding members that are less than or equal to the grad year and in good standing, and remove everybody that's in under that. So the good standing ones get added to the array list. Everybody under that gets removed. Now, the key here is in this particular step, it's not asking whether they've screwed up on, and for those of you who know about the array list removal problem, where when we iterate through an array, if we remove something, it shifts all the indexes, and therefore there are several ways that students can go about that, either by iterating in reverse or by adding a little I minus phrase, or there's some other techniques for doing it. It's not concerned about that. It's just asking, do you have the right logical order to ask, is this member in good standing? Is their grad year less than or equal to? If it's both of those, then it gets added. Either way, they get removed. And then finally, it says remove all objects that are not in good standing. In this case, they just have to have that less than or equal to sign, comparing grad year to the object, and get grad year. Finally, question 6 or point 6 is the one that says, hey, do you have that array list removal problem figured out? In other words, do we have these wrong, like you end up skipping over people, then you haven't removed all the right people. This one is a challenging one. I think students need to get pretty fluent over time. It's become a big goal of mine for students to be fluent with iterating through arrays and array lists, knowing the syntax of arrays and array lists, understanding that we can have objects in arrays and how to manage and call methods on objects. Later on, it might be comparing objects with dot equals. This one doesn't actually have us do that, but those are all what I would say is algorithmic thinking. And so as I get to this part of, here we are in unit 6 and 7, I'm beginning to teach my students to understand general algorithms. How do I add things? How do I remove things? How do I search for the biggest or the smallest, or come up with an average, or come up with doing something in reverse, or doing something to create a new thing? If they have those general skills through practice, through working together, these become a lot easier to work through. I'm going to stop here for just a second and see if anyone has any specific questions about what it's like to be a grader, or how it is that we students can approach as they go. So, David, if they do all of the things individually, but the code doesn't work as intended, there were a couple of instances where I could identify little pieces and say, well, that piece is there, this piece is there, and the third piece is there. But technically, will you go back one slide, Pauline? Oh, sorry, there you go. There we go. If they iterate through every item in the array, it would ask you to add them to the instance variable list, the member list. If you, for some reason, iterated through, constructed new members, but then outside of the array, added them to the member list somehow, that would be considered not getting number 3. In other words, you understood that you were going to use a list, you understood you needed to create new objects, but you didn't actually, in the context of the list, add them all to the member list. So it's, in a moment, you'll see that there are errors that are forgiven, quite a few errors that are forgiven, as long as the logic and the intended purpose of the algorithm is there. So, David, I mean, I can answer you somewhat exactly, and if anyone wants to step in and give him a better response, but you can accomplish all things individually, but the code might not work if you typed it into an IDE and ran it, because there may be syntax issues that are not considered a earnable part of the or a part that would detract from getting points on the FRQ. Why don't we actually go ahead to 2 slides, and I'll show you a little bit of what this looks like. So this is written on every FRQ page, this little phrase, and I'm going to read it out loud, because if you listen to it, you'll kind of hear how we as graders approach it. We look at the scoring rubric first, and we ask the question, which points did they get? We don't go in and do any penalty points until they've earned the point on that part to begin with. So if they do something on like part A, and they don't earn any points to begin with, I can't give them a negative point. So no part can have a negative total. And a penalty can only be assessed once. So if they make the same mistake 3 times, they don't lose 3 points. They just lose 1 point for doing it. And for any question, a maximum of 3 penalty points, even though there might be 4 or 5 possible, there's only a maximum of 3 of those. Now, an example of this was, that number 6 on the list, the last one on the second answer, where they ask, I'm sorry, not that one. It was the 3rd point, where you either use get grad year or in good standing. It says you can earn the point even if they call only one of the 2 methods, right? So that there will be plenty of students who forget to call one or only call one of the 2, and they still get a point for understanding they need to call methods on an object. They don't earn the point if they include parameters, because neither of those methods include parameters. Or if they call the method on an object other than a member info object. In other words, they have to know that they're using an object to call a method on and that it doesn't require a parameter, but they just need to do it once. So that's kind of a way that you look at the way I would approach that, is that, do they get the point or not, and then remove it. On the next slide, I believe is the next slide, is what does and doesn't get a penalty. And you can read this over, but I'm going to give you a general idea. No penalty if they go off on some tangent writing extra code that doesn't affect the overall process. They're not going to lose points. It doesn't help in the readability of their problem, but it's not an issue. For instance, I had students who went in and tried to write a new code that does the dot compares for strings, like tried to write their own alphabetic code using chars and char at, and it was like brilliant, but it actually meant nothing because all they wanted them to use was compare to, right? Spelling or case discrepancies, as long as there's no ambiguity. And the point here is that occasionally you need to be really careful about the names of classes, the names of instance variables need to match. But so long as it's clear what they intended to do, we as graders try not to give any penalty. If you have a local variable that's not declared, given that other variables are declared in some part, in other words, like it's possible that you have a count that you're adding and it doesn't get declared, but you're counting, you're doing the summing that you're supposed to, it works. Stephanie, we will have the video available, so don't worry. Finally, things like public on a class constructor or header, they don't require that. They do ask that you have private on instance variables. Using a keyword as an identifier, so they don't dock you for accidentally calling something new, even though that wouldn't work. And then basically the symbols. We do our best as graders to assume symbols. Curly brackets, square brackets, parentheses, carets, equals, not equals, using mathematical symbols versus the traditional computational ones. As long as it's implied clearly from the student, they're not going to have any issues with that. The other one that's nice is equals versus equals equals. So long as you're clearly trying to compare and do a Boolean operation, they're going to assume that it's equals equals. Let's see, length or size confusion for arrays, strings, lists, or array lists without putting the size in the parentheses. They just make assumptions about what you build in terms of the initial sizes of those. Basically, as long as it's clear and intention is there, we're going to assume that they've got their braces, their brackets, their semicolons, and everything else exactly where it needs to be. And generally, the only thing that will happen is if their sequencing is off. If they try to do one thing before they do another, and that would throw it off, then the assumption is that they would have sequenced it properly, but indenting and so forth isn't going to get docked. Now, if you forget with arrays and array lists to use array list methods versus array methods in terms of like identifying items in an array, they will have a problem with that. If you create code that causes a side effect, like instead of returning something, they do systemout.println, that's going to be a minus. They need to return that value. Or an incorrect precondition check, like they make assumptions about what the precondition of some variable coming in or a parameter coming into a method. Finally, destruction of persistent data, in other words, changing a value referenced by a parameter or a void method that returns a value, so in other words, you have a void, but you tell it to return, those are going to be docked a point. I did a whole lot. I did hundreds of these, of the one you just saw, that club members, and minus points were rare. They happened occasionally, and they happened usually in situations where students were sort of doing what I said, like where they kind of they throw like the spaghetti at the wall and they just see what sticks, and you're not sure, kind of, they have this massive code and you're trying to figure out what it's supposed to do. And they're creating all these problems that make things worse. That tends to be the situation where there's going to be some minuses. For the most part, if a student knows what their approach is, they tend to do a pretty good job. Does anyone else have questions at this point? Because I can then talk about some strategies, and I think we'll have a chance to have people kind of share other things that they've done. I'm not sure if Kate's waiting to tell me something that I don't know, but she's got far more experience doing readings than I do, so. David, yeah, some of the no penalty items are things they do need to know on the multiple choice. And so indeed, they will, the multiple choice questions will not have substituted syntax, but they might have improper syntax of more detailed types that students need to be aware of and be able to identify. One of the things that, and I'm going to just point out something I learned, and I learned through working with CSAwesome in my first year, is that the more you have your students type all of their code in an IDE properly, rather than copying and pasting or using autofill IDEs, the better they get at both reading at multiple choice questions and completing FRQs properly. There is a fluency that comes from having to do it every time. My students get mad at me when I'm like, when I say, you know, public static void main string args, like, again, yes, you got to type every letter here. There is no autofill on my IDE that we use. So indeed, I think those penalty items that you see here are important things for students to identify as they look at multiple choice questions, because you really are thinking like a computer when you go into those multiple choice questions. Let's go to the next slide. So I've made a list of thoughts and frequently asked questions that I've gotten over the years about FRQs. The first one, hopefully you know the answer to this. If you get one part wrong, it doesn't really affect the others. For the most part, that doesn't happen. And so you can let your students know, like, it's okay if that one thing that you're supposed to figure out, something you're supposed to use a modulus and you forgot how to use it, like, it's not going to ruin the whole FRQ. Keep going. Just assume it works. Focus on what's earning points. Even code that doesn't compile earns points. So creating variables, inserting or iteration and transversing, return value, all that stuff is helpful. And so as long as they start laying down the general idea, they're going to start getting points. I've had students who have terrible handwriting. I had one student who did get accommodation from the College Board to use a computer, but that was, I think, figured out early in the year. I'm not sure how quickly College Board will give those accommodations. I do ask students to work on it and practice it. I know that as a reader, if we can't read something, we hand it to someone else. If they can't read it, they hand it to someone else, and then they have 2 or 3 people look at it and try to figure it out. But you definitely don't want to lose because of your handwriting. It doesn't have to be perfect, but it should be careful. I don't think we've talked about this, but we know there's 4 different types of FRQs. Your students should know what they're strongest in, what they feel most confident approaching, And rather than going through the FRQs 1, 2, 3, 4 necessarily, they should jump to the one that they feel most confident and really feel like they're going to get the best at that. They should probably be working on the one that they're the least confident on last, in case they run out of time, because you don't want to run out of time knowing you could have done better. Using scoring rubrics every time. So I get rid of the rubric over time, but I then ask the students before I grade their FRQs, we come back to class on a summative test, and I say, okay, here's the scoring rubric, give yourself a score. And then I look at their scoring and I decide whether or not I think they scored it right. And we get into arguments and it's fun, but it allows them to really think about the process of what's going to be scored. AP Classroom has a self-scoring option on their progress checks. So if you do the progress check FRQs, there's a little button in the bottom that allows you to ask students to self-score them. So they complete it, then it says, okay, give yourself a score. Then you can see what they think they did on it, and you can give them a score and check off boxes to see what they got. So that's a great option. I think it's new this year, or maybe I didn't know it was there last year, but it's super helpful. Practice, practice, practice. That's Leanne's point. I said it, I'll say it again. Remember, average scores on FRQs typically range from 3 to 5 points out of 9. So if you look at the mean scores or median scores from each FRQ year after year after year, the difficult ones might get a score of 2.8 or 3.1. The easier ones might be a 5, a little over a 5, but not everyone's getting a 9. A student who doesn't get a 9 doesn't necessarily not get a 5. And reminding them that perfection is rare on this exam, and it's very rare on all 4 FRQs. So they're really asking them to get a majority of the points to stay in the running and do a great job. And rather than getting students feeling a sense of loss and inability to succeed. Let's go on. I think we've got just enough time. So these were questions that were dropped in at the beginning. Is that right, Pauline, from some of you? Hopefully we've answered some of these. How we break down an FRQ, I think that was pretty clear. The AP course audit, I'm sure Pauline can say more about it, but the AP course audit is more about how you propose your curriculum to the AP board to be approved as an AP teacher. And if, for instance, if you do the CSAwesome curriculum and you do training with us, we've got the CSAwesome syllabus that you would hand in, but it's not specifically tied to FRQs. FRQs are a part of what you'll be teaching students. And then as far as the rubric is concerned on FRQs, hopefully I gave you a chance to kind of understand better what us graders are doing in order to identify where you get points and don't. I do encourage every single one of you. Now it's funny because for years I wouldn't do it. I didn't want to do grading because I hate grading. I hate grading in general. But doing the reading for the College Board made me a much better teacher of CSA. And I wish I could explain exactly why that is, but being familiar with student responses and the full scope of what's possible and how many ways they can solve a problem really opened my eyes to how I can teach it. And I feel so much better about teaching FRQs having done it. And the College Board is always looking for people to help do it. So if you feel confident and you want to give it a try, it's worth it. I'm going to hand it over to you, Pauline.
Thanks, Ben. So as we close out tonight, we have a couple of things for you. In the slide deck, there's lots of additional resources and links. So hopefully you have the link to that. If not, we will share out the recording and it will be available on our YouTube channel as well. But before you skip out, we have two very important things for you. I'm going to need to exit out for a second here. All right. So if you kind of enjoyed what you heard tonight and you would like more professional development and maybe the opportunity to work with Leigh or Ben for an entire academic year, we invite you to apply for our professional development. We have two awesome, pun intended, two awesome opportunities for you. If you are new to Java and CSA, which I said at the beginning, if you were here, that many of you were, according to our registration form, that you may be eligible for our research project, which is funded by the National Science Foundation, and that includes free professional development this summer and the opportunity to earn up to $1,500 in stipends. And it includes support from PD facilitators and experienced CSAwesome teachers for an entire academic year as you're teaching the course. So if you are new to CSA in Java, we'd love to have you submit an application at rpp.csawesome.org. We're looking to kind of get that cohort filled before the start of May. So the sooner you get your application in, the better. And we also have another opportunity for all public US high school teachers. You are eligible to participate in CSAwesome professional development for free, thanks to funding from the Infosys Foundation USA. CSAwesome will be a part of the Pathfinders Online Institute 2022. So you can go over to csawesome.org/pathfinders to see more information there and to submit an application. All that's needed for that is you would submit a letter of support from your administrator saying that you're able to participate in the PD and that you are interested in using the curriculum to some extent. That means it could be supplemental, it could be for the entire year. It's just that you intend to use the curriculum in some way. And that is happening July 25th through 29th. If you're new to Java for that one, it does have some pre-work to it, but I can say we know that Ben is going to be our facilitator for that PD, so we're looking forward to that one. So two really awesome PD opportunities. If neither of these kind of sound like what you're looking for, I'm always happy to help answer questions. Feel free to reach out to me at ed@css.edu. And of course, if you have any questions, please contact us. And we'd love to have you complete our exit survey. We do offer these webinars free of charge, and we'd love to be able to continue doing that. And we use your feedback to help us plan them. So if you can go ahead and just take a couple minutes to complete the brief survey, that would be greatly appreciated. We thank you all for joining us tonight and for your participation, and thank you to Leigh and Ben for being our guest speakers. I hope that we'll see you in the future, and if not, we'll see you on the forums. Thanks, everyone.